All right, let's look at the homework 15, problem number 4. All right, so we want to find the area of the parabola inside the cylinder. X squared plus y squared equals 9. All right, so let's sketch this cylinder first, at least just circle there. So radius is going to be 3, right? So I'm going to just draw that. So this is the intersection of the cylinder, and the xy plane should look something like that. All right, so since radius is 3, so that's going to be 3 there, and here 3 there, and that's -3, and here -3. All right, then we have a parabola. So let's see, I'm gonna try to draw a parabola. So it's going to look kind of like this. All right, so a parabola is going to look, oops, that's not what I want. Parabola going to look somewhat like that. All right. Then what we want to do is we want to cut it using the cylinder. So a cylinder would go up, would go straight up there, and would go straight up there. Then you would have a circle, let's see, somewhere around there. So it's actually not, yeah, that doesn't look good. Maybe I'll try again. It's more like here, right? So inside the cylinder, actually, that looks really bad. All right, let me try that again. I'm gonna just try to draw a circle. It's gotta be, yeah, it's something like that, right? That looks better. All right, so inside, so the surface would be this surface right here. So I'm gonna just shade it. So whoops. Right, so this is the surface that we're talking about, right? And back side too. Right, so we want to find the area of the portion of the paraboloid inside the cylinder, which looks kind of like this. All right, hopefully you can kind of visualize that. All right, so this is what we're doing. All right, so remember that we need to have the let's see, f function. I'm going to rewrite this equation, the equation for the paraboloid, as I'm just going to put all the terms to the right, and you have a z, and you have a minus x squared minus y squared, right? And so that's equal to 0. Same equation, right? And I'm gonna call this this equation right here, this guy, this function, as f. So this guy is f of x comma y comma z. All right. So first we're gonna find the gradient. So gradient of f would be, all right, partial of this function with respect to x is -2x. Partial with respect to y would be -2y. All right, partial of this with respect to z would be 1. All right, then we can find the secant of gamma. Right, secant of gamma, right, is equal to, all right, secant of gamma is just the magnitude of the gradient of f over absolute value of the partial of f with respect to z, right? So in this case, we're going to have square root of, all right, so you have this guy squared. So I'm going to just go ahead and write 4x squared plus this guy squared would be 4y squared, and a 1 squared would be 1 over, all right, partial of f with respect to z is this guy 1, right? So we get that. So we just get, all right, I'm going to write it as square root of 4 times and x squared plus y squared plus 1. Right? Then we just need to do the integral. So we have we're going to have a surface area A is going to be, right, integral over, right, so this is the disk, right, so I'm going to call this, so this is the disk on the bottom, so disk right here, and including those. So disk with radius 3, I'm going to call this disk D. Right, so you have integral over D, right? Secant of gamma is square root of 4 quantity x squared plus y squared plus 1 dx dy. Right, but since this is a round object, it is easier to evaluate it in polar coordinate. Right, so let's do a polar coordinate. So here is integral here. All right, then we can do maybe r dr d theta. Right, then here remember that r squared is same as the x squared plus y squared. Right, so we can rewrite this guy as square root of 4r squared plus 1. Right, then polar coordinates easy to set up. Fixed theta, radius is going from 0 to 3, so r is going from 0 to 3. Right, then theta is going to go from, you have to cover the entire thing, so it's going to be theta is going to go from 0 to theta equals 2 pi. Right, I think you can evaluate this guy. Right, so I'll let you do that. Right, that's it. I hope that this will get you going.